morning, everyone. Welcome back to the live. So I hope you all doing good. So today we're gonna start the sessions with this finger tracking AI. So it's a basic concept of artificial intelligence where we are giving training on the finger tracking and face recognition software. So we're gonna use the finger tracking recognition extension in the PictoBlock. So let's go to PictoBlocks. So as I want to, yeah, I want to tell you about this PictoBlocks application where you can download in your systems. So I'm gonna show you that. So this is the web application where I gonna use the program. You can also use this, and you have to sign in for you have to sign in for giving getting the extension. So I'm gonna use it like, so if you have not done it before, please do sign in. Or you can just register as a teacher or student. You can register like teacher. Yeah, I'll just do sign in. So 1 second just. Actually, I needed the display. I'm sorry, there's a technical error. I just want to deconfirm my email. Give me 1 second. So actually, today we're gonna use the finger human body detection AI extension. So you can just directly go there and click on it. It will download in your programming block. So while it gets download, so we'll just get to know about what is the finger tracking AI. So in this session, you will understand how to move a sprite in a PictoBlocks by tracing your finger in the air, like not in the air, but on the camera. So we're gonna use the camera to detect our fingers, the every dot of our finger, and we're gonna use the hand to move the ball, which is technically a sprite. So yeah, and for that we have to select a ball instead of Toby. So here we got all the, so here at the bottom of this block you will find the human body detection extension, right? Yeah, so we need to delete Toby first. So for that we are going into this block and deleting Toby here, and we have to choose sprite of a ball. So this is a ball where we're gonna control the ball using our fingers, and so we have already downloaded this extension. If somebody didn't do it, please try to do it. So you will find this extension here on the bottom. here, top left corner, sorry, bottom left corner. So this is the human body detection extension that we're going to use today. So please just click on it, it will directly add. So then program. So this is the program that we're gonna use for the finger detection. I'm just gonna display it for few minutes so that you will follow, and I'll also do it parallelly. Just want to give an update. So we have one more trainer who is looking upon the chats as well. I'm also looking for the chat. So if anyone have any queries, please drop it in the chat box and make this a little interactive, right? So I can see all the good mornings here, but if you have any, like even I have to slow down a little bit, or if the program is done I have to change the slide, please let me know in the comment box so that the session will be interactive. Yeah, so now we have to start programming. So this is, we'll go for that, we'll go to the programming block. Here you will find, in the events you will find when flag is clicked. So we'll drag and drop it here. Then so we have to set size of the ball to 60. So this is the program for the ball. So in looks we will go to set size to 60%. To select this entire thing and 60%. Then we have to turn on the video with transparency 0%. So for that we'll go to left corner, tap on human body detection, turn on video stage with 0% transparency. So you can change the transparency here from 0 to 100 scale, so that you can see your face in the compiling box, right? Yeah, and then we have to go to forever loop. So forever loops are in the control block, because we can the blocks we are using. So all this wait, repeat, forever, conditions like if else, or wait until, these are all the control blocks where we are controlling the programs. So yeah. So we'll have again the forever block, and we have to analyze the image from the hand. So we have to analyze the image of the hand. So for that we'll go again in the human body detection, take this block, analyze image from the hand, sorry, analyze the image of the hand. So again now we have to use a condition. If the hand is detected, then we have to set the x and y positions. So yesterday we have discussed about a 2D plane, right? So in a 2D plane we have two axes, x axis and y axis. X is horizontal and y is vertical, right? So this horizontal and vertical positions are being used to detect the position of the hand in the entire plot, 2D plot. So if it's a 3D plot, we are not going to use 3D here. but if it's the 3D plot, we'll use X, Y, and Z. So Z will be the width of it. So we can say depth. So if it is too much forward, and so it will be positive Z, and if it is too much backward, it will be positive, sorry, negative Z. So we have set the position, or we have to set the position of X and Y to the top of the index finger, because so as a camera sees this part, so we want the camera to analyze the tip of the index finger. You can also put tip of your middle finger. So most of the people will have the same size of the three fingers, because it will be, so if you look like this will be the middle part. So even here we need symmetry. So all these plots like hand detection or face analyzation, we need the golden ratio. So if somebody doesn't know the golden ratio, I'll just show you. So yeah. So this is the golden ratio, as you all know. So this is the image for it. So this by using this, we use lot of like architecture. Yesterday also we have discussed this thing. So this ratio is used for the perfect symmetry. So for the taking reference of the perfect symmetry, we train the robot or the model to understand the middle point and the end points of a particular object. So now here our object is the hand. So we start with the index finger and we take the entire hand position, right? So this is a the analyzing objects or the parts are very important in the AI. So we are discussing this much theory about it. So again we'll continue to the program. So yeah, if the hand is detected, then set Y position to the top of index finger and X position to the top of finger. So the set block, okay, we'll go to event control for if block, if and then if the hand is detected. So when we put hand on the camera, then set X, set Y. We have taken two blocks. Set X. So we have hand detection, top of index finger. You can also choose another, like if you are doing another project, we can also use thumb as a middle point, or ring finger, pinky finger. So you will get to know in the next programs how to use these kinds of. So we are changing Y, top of index finger. So you can use this or you can use this block. So anything is fine. So let's run the program. So when you run the program, it asks, okay, 1 second, just anyway they can see me from the camera. I'm just doing it. You can check.
Yeah.
Okay. So sorry for the interruption. So yeah, you can restart the camera here. I have to do the program again. So we'll quickly. So this will be like a recap also. So we'll take a ball and delete Toby. We don't need Toby. Go to events. When flag is clicked, then set size of the ball to 60, which is done. Now turn on the camera. For that we need our human body extension. So to turn on the video with 0% transparency, we don't need transparency. Then we'll take forever block and analyze the image of the hand. For that we'll go to bottom left corner, analyze the hand. Then we'll take if and then block. If hand is detected, then we'll go to looks. Take x-axis, y-axis. Again, we'll go to this. We have to set the x position to top of the index finger. I have to select top of the index finger and set y position. Set y position to top of index finger and we'll run the program. So that's what happened. I have to do it again. Can you please check? I'm sorry, teachers. So this is actually my system's camera is being used by the stream already. So I'm gonna present it in my tab. So if it is visible, please let me know in the comment box. So this will be the same PictoBlocks that we are using it here. The program is same and I'll just show you the output in the thing. You can just follow up. So in the meanwhile, you can just log in to your PictoBlocks. You can just sign in and register till we rectify our problem here. So this is how the output will look. Yeah, but I don't feel it is. Have to go according to the plan, right? Okay. Can I check it here? So it's done. No camera. Anyway, I have to show it, right? No, no, no. I'm asking. Okay. So that is there. No, no, it's okay. It's okay. Yeah, yeah, yeah. Fine, fine, fine. So I guess you all can see me on the camera. So this is how it is looking like. So yeah. So I'll just show you the output of this program. For that we need so I'm just trying to reconnect here with this program. So and yeah, if you tried it on, you can just check it from pressing the green flag. So this will be the output. So you just try to move your finger here around the camera so that you can just see the ball moving with you. So like up, down, left and right. So and you have a challenge here. So if you want to add few more balls and track with your fingers, so that would be great. And please try it out. You can also change the colors of the characters while using, yeah. So if you want to add, we have you can add these kinds of balls like basketball or any other sprite. So while you are doing the control, you can just add the program to the, so if you take any other sprite also it's fine, so you can move around with your fingers. So yeah, so if you have any doubts, please tell me in the comment box. Yeah, and so now we'll just go to the next slide, which is creating a space battle game. Okay. Even for that, we are using human body detection here. So now I guess, as you all know, we have created a space battle game yesterday in this program, and today we're gonna do it with the hand gestures, right? It is interesting. So yeah, this is how like what we're gonna do. So we can control the rocket ship with your fingers here rather than using the keys which on your keyboard. So let's start making the game. So for that, first we need to add the human body detection extension here. So it's already added for us, and for that you all know this will be the program. For the same, or actually you can use the same project uh, of this sprite. So only for the rocket we have to change the program. So when flag is clicked, so you have to turn on the video transparency to 50%, set size to 40, and we have to move the rocket for like setting up it to 0 of the x-axis and minus 140 of the y-axis, so that it will be on the bottom of the screen. And then we have can put the sound of our wish, and then have to use the forever block and analyze the image from the hand, analyze the image of the hand from the camera. So if the space key is pressed, then we have to create a clone of a bullet. So similarly, like just we did the program in the previous session, so we just had to add the space hand gesture extension here, and then create a clone of a bullet. We have to wait for 0.1 seconds. If the hand is detected, then set the X position of to the top of the index finger, and we have to set the y-axis to -40. yeah, I'll also put this program for your reference. So if any doubts are there, please let me know in the comment box. So this is how the program will execute. So you can control the rocket ship. So let it be like a challenge for you. So you can do okay. You can just copy the program for now, and you can do the program like you can add this program in the rocket ship uh, for the previous project what we did yesterday, and you can continue. So yeah, thank you. We're gonna move on to the next slide for today, and just give me one second. Yeah. So the next topic is doing emotions with Quarky. So in this topic, I'll let you know about how to connect the Quarky, this robot. So I guess you all will get the Quarky robots for this making prototypes and everything. So this is Quarky, as you all know. You all saw it yesterday. So this is a robot which we're gonna connect to the program and see it working. Just like a hands-on activity. So yeah, for that we have to connect to Quarky with. Okay, sorry, yeah. For that we need to connect Quarky with the USB, which is already connected to my computer. So anyway, we'll connect it here, and then we'll go to PictoBlocks and select board, which is Quarky. And we connect it by using serial port, which is communication port number 8. So I'm connecting it. So now the Quarky is connected. So just for test, okay, yeah. And these are about the components and the features of the Quarky robot. So as you all can see, so the power switch is underneath here. To switch it on or off, we use this power switch here, and this whole area is 7 into 5 RGB LED display. You know the LED, right? So we are using RGB LEDs, just like a matrix, to display something. Just how just like the monitors or the TVs will work by using, like, pixels, right? So we can call each one of this LED as a pixel. And we have two proximity sensors uh, over here and here. So this proximity sensors are technically infrared based sensors. So you know the infrared light, right? So how can I say, yeah, we use remote control, or in the mall we see the automatic doors, right? So when we pass on, the doors will automatically open. So we use these kinds of sensors there. So actually you can't see the light through your naked eye, so but you see these two lights here on the camera, right? So these this is like infrared light or infrared rays which are passing from the sensor. So this will be like, so if one ray is transmitted from one end of the sensor, it will get reflected to the another side of the sensor. So that's how it can measure distances. It can like detect the objects, or it can follow the line as well. So you can measure the intensity of the light which is reflecting back. So that's how if we, so for suppose uh, if there is a white background and we put a laser light, it will get reflected a little, right? And if it is a black color wall or black background, so if we put a light there, it won't get reflected back. So that's how we will measure. So there we are getting the intensity of the light, and that's how we will measure the intensity of infrared light that we are receiving back. So by that we can analyze whether it's an object or it's a line, or um, it's a white color background or black color background or whatever. And then so there is one more reset switch here. So this tiny little switch is a reset switch. So if you have any other program already running in your Quarky, if you press the reset button, it will reset automatically. And we have USB Type C, that you all know. There are two tactile switches. So these two are uh, the left, and in the left and right we have two tactile switches. So where we can tap on the switch or press the button. So we can use it like a button. So in the program there is in the events we can also see when space is pressed, when tactile button is pressed, any key is pressed. So we can use this for the buttons. Then we have two servo ports, and here and here. So by using these servo ports we can attach a servo motor which actually moves sequentially, like left as an example I would like to say there is wipers for our car, right? So there are few wipers for the car. So for that we use these kind of servo motors. So you will get to learn about the servo motors later on in your, like how to use in the program. And here we are using the servo motor for grabbing objects like open, close. Yeah. So this sequential motor helps us to hold the things and release. But this is even these are the motors, but these are not sequential motor. They can just move clockwise or anti-clockwise. So that was the major difference. And then we have a tiny little speaker where we can see the Quarky speaking, and there are light indicators, and there are 6 generic input ports. So these are input ports where we connect any other external sensor. And yeah, so as you all know, you can control Quarky using Wi-Fi, Bluetooth, and you can also use it by serial. Yeah, this is how we connect from the desktop. You all know how to connect the Quarky. And So again, I'm just repeating how to connect Quarky. Here we have to switch on the Quarky, open the PictoBlocks, and you can go to MySpace and click a new project. And there you can, after creating a new project, we have to select the board in the toolbar, and we have to select the board as Quarky. And then in here, you can just press connect like this. That's it. And we have to select the device from the list. So Quarky BLE. You can also connect the Quarky by using you can also connect the Quarky by using your mobile phone. So here is a tab. I have the Android application of Quarky, PictoBlocks. Yeah. So I have the Android application of PictoBlocks. When I open, and I created one new file here, and so similarly we can control or connect the Quarky by using the Android device. So we'll have select the board and then connect Quarky by using Bluetooth. So I can connect the Quarky by using the port Quarky 009E, right? So you can see it. So I can connect it. So it gets connected, and then you can actually use it wirelessly. So when I press forward, it will move forward. So when I press backward, it will move backward. Yeah, that's how it works. Yeah. And now we're gonna do emotions with Quarky here, and for that I'll disconnect it from my tab. And yeah, so the program is, when we press up arrow, we have to display emotion: angry, crying, love, so here we're gonna use one more event, which is key pressed, and we're gonna take Quarky's display. Let's put it here. So when up arrow is pressed, display happy emotion. So you can right click on the block and you can duplicate the block. So if you are using similar kind of blocks, so you can right click on the same block and you can duplicate it. So I'm gonna use up arrow, down arrow, right arrow and left arrow here, just like the controls of the game. And we have happy, angry, basic and crying emotions here. So I'm just changing. Let's run the program. So I'm pressing green flag. The green flag is clicked. So I have pressed the left arrow in my keyboard, so it's changing the emotion. This is right, down arrow, up arrow. So this is how we can make this thing. So you can also add one extension like a face here and make it work like a robot face. Yeah, thank you. And now we're gonna move on to the next slide, which is making a rainbow animation using PictoBlocks. So this is the program for Toby, and also we need to put one rainbow sprite here. So we all know how to take the sprite. So let's delete all of the program. Done. And we need a Toby. and a rainbow. Let's search for rainbow, and we'll select a backdrop of a, so yeah, I'll just take space backdrop here, make it look more colorful, and we'll select Toby first and we'll program. So this is the program for Toby. When the flag is clicked, go to events. When the flag is clicked, set size to, so say press the left and right button of the Quarky to animate the rainbow. So you can type it, you can select the block and you can type the text in this block. And then we'll take forever block. Have to switch the costume and wait for seconds and Toby walking. Take forever block, go to looks, switch costume to Toby, and we'll go to events, wait for 0.4 seconds, it's enough, and we can duplicate code program and we'll change Toby walking 3. So let's check. So this is how we can make Toby move his face. So that's how he'll like it looks like he is talking something. So he's saying, so press left and right button to animate the rainbow. So this is just like a program guide when you are playing the game. And yeah. And now we'll let's code the rainbow sprite. We'll select the rainbow sprite first. When flag is clicked, you have to set size of the rainbow here somewhere, and we'll change the size to 200%. For that we'll go to looks and set size of the rainbow to 200%. Then we'll take one forever block, and we have two conditions. When button L is pressed, change the color effect by 15, and if the right is pressed, change the color effect by -50. So for that we need forever block. If and sensors, we have left button is pressed, and go to looks, change color effect by 15 points, and then we'll duplicate this block, right click, duplicate, put it here. When button R is pressed, change the color effect by -50. So we'll click on flag. So when we press the button here on the Quarky, so it is, the rainbow is changing. You can see it, right? So if you press and hold, the rainbow will animate. So I'm actually pressing the buttons here, right and left. So we are changing the intensity of the colors in the rainbow. So yeah, actually you can put any other buttons here. So let's try without Quarky. So you go to keys, sensing. When key space or up arrow, let's say up arrow is pressed, and here we'll put down arrow. You can also use this if you don't have Quarky. Yeah, you don't have. So if I am pressing up arrow and down arrow here, so the color intensity is changing according to this. So this is how we can integrate Quarky also in the program. And all the times it doesn't need to be connected to the system by using wire. You can also use your wireless connectivity, just like Wi-Fi or Bluetooth. You can directly connect the Quarky by using Bluetooth here. I'm using the serial because it's a faster way of communication than Bluetooth. Yeah. And you can see the output just like this. And we have one more. So I guess we can continue for the next project. For that, let's save this project. So for saving the project, we have to go to the save block, and the project will be saved directly into your downloads. And then you can delete your program. Now next project is like beating the heart with Quarky. So we have this display on Quarky, right? So we are using the display to create a heartbeat emoji or heartbeat animation on the top of the screen of this LED matrix. Then for that we need Quarky, obviously, and then we need a forever block to control the palette on the flag. So this is how the program. So for that we need to create a little tiny animation here. So let's start with the program. So we don't need the backdrop or anything. So I'm just putting a plain backdrop, which is hearts, and I'll delete the rainbow. I'll delete the Toby as well. So we can directly program the Quarky. So for that I'm taking when flag is clicked, forever block. In that I'm adding display. So display matrix as. So here we can use this with any other color. So you can fill any other color of your like here. So I'm adding red and blue. So you just have to select the series of LEDs and make them glow. So this is done, and I'm gonna wait 1 second. So we need the heart to be like going up and down, like as it has to look like it's beating. So we'll go to once and wait 0.1 second, and duplicate the entire block, and here we have to change the block to blue, this color one, and make the heart look a little smaller. Now let's try out the program. So you can see the let me make it's not visible so much, so I'll just LED off. I'll set LED off, switch off all the blue LEDs because the blue light intensity is more on the camera, right? So I'll just do it and then switch off the LEDs. It's done. Now let's check. So this is how we create an animation of a beating heart on Quarky LED. So you can also do it on the screen, this console box. I'll just display the program for a few seconds. If anyone is following up, you can just copy the program. So our next project will be traffic lights with Quarky. So I know you all don't have the Quarky robot here, so you might be receiving it later on in this few days. So let's focus more on like training on the robot and how to program, how to connect and everything, so that it will be familiar of like working with the Quarky. And as you all know, this is the display this red in the project of traffic signals. We have to select three different colors, which are red, yellow and green. So we have to animate in such a way that the Quarky will change its display for every, like the red will be more like 5 seconds, and yellow will be of 0.2 seconds or 0.3 seconds, and green will be for 2 seconds. That's how we animate. So it will be like an automatic street lights. So this will be the entire program. So let's do the. So we need forever block, usual, and we have to make everything red. And wait 0.1 seconds and have to display. I'm removing this block. So we are changing the color, putting the number, just like sequence, like 3, 2, 1 are there, right? So should we start with 2 in some other yellow color. Or red. we are duplicating the block and we have to display 1. Change the to 0.5. It will be there for 1 second. It will be there for 0.5 seconds. And then we can duplicate this block, put it at the bottom. And we are changing the color of the matrix here to yellow. Fill up the color and then we go to events, wait for 1 second, then we'll duplicate the entire block, put it here, make the entire this thing green, and we can also change the numbers like this. Okay, let's test it. So here we need the red to be a little more because the red signal will be more on the traffic light. So we'll wait for 3 seconds and yellow for 1 second, green for 2 seconds. Let's try. So this is how it's working. And yeah, we finished another project also. So I would like to give a break of 5 minutes to analyze all the programs that you have done till now. So we read 4 projects, 3 with Quarky and 1 with the AI hand gesture control. So I would like you guys to revise in the break. So I'm going to go. Welcome back. We need so if you have any queries in the comment box, I would like to know. So please, if anyone has this, so I'm checking the chats. So if you have any queries or any following up the other programs as well, you can just let me know. I'll just display the previous program, or you can just go back on the live video, and you can just take a screenshot of the project. I would like to give a 5 minute break, a quick break. So we'll continue the class on AI. So it's mostly on theory. So let's do it. So welcome back on the live. So we're gonna learn about face recognition theory. So we'll start it today, and we're gonna end it by 10:30. And because we have another session going on, so let's talk about face recognition today, and the project we can do it in the next session. So that's what I feel. So the finger detection, as you all know, we have created one project, and yeah. So this is how the activity goes. You'll have face detection, know about face detection in image, face detection using PictoBlocks we're gonna do a program, facial recognition and its project activity. So yeah, so this is how the project will look like. So you can detect the age and the gender by using uh, this AI extension in the PictoBlocks that we already have used. I'll just take a new file. So as you all know, we're gonna use the same face recognition plot, and we have to select face recognition extension. We have to download, and then okay, how we detect faces is like just like we just have learned about the golden ratio, right? So even for the face of a human, we will use the ratio actually to analyze the symmetry between eyes, nose, and the mouth. So as you all can see this figure, so the distance between eyes and the distance from the tip of the eye nose to the bottom of the nose, and the uh, points of left and right lip tips. So this is how we can analyze a person's face, and we can train up the AI in such a way. So and we're gonna use this all blocks to program the face recognition. And we the feature based detection is one more method. So here it can detect by using the landmark of the faces, which is also called as face landmarks. So there are usually 68 preferred landmark points of a face. If you can see, so for example, some human face are a little broader and depending upon the territory of their living, and some faces are more round and some faces are like the jawline is different. So these are all the features of the face that we can train up the AI in such way that it will recognize a particular face. Yeah, and so if we go more on the knowledge based detection, so there are these are the advantages, like have easy to come up with simple rules, and based on the code rule, the facial features in the input image are extracted first and the facial candidate are identified. Just like you use the face recognition in your phone, so this method of knowledge based detection is used in the face unlock of your phone. And the disadvantages are like it is difficult to translate the human knowledge into the rules precisely, and the details rules fail to detect the faces, like there are two eyes in a person, and general rules may find very like false positive, like there is an eye in the face. According to this, the face will be identified and the statue of the similar looking eye. This can also happen sometimes because um, the AI cannot tell in this method the AI cannot tell whether the eye is moving or eye is not moving. So even if it's a tattoo, it gets confused, and then it will give an output that the eye one eye is there. So this approach alone is insufficient to find the matches in many faces and multiple images. And this feature based detection is like invariant to pose and orientation change, and this method has a higher chance of getting the face detection. So it is also difficult to locate the features due to the noise in the images. The difficult to detect the features in the complex background is also a little disadvantage, but I can say but the space based feature based detection is more accurate than the knowledge based detection. So we're gonna use the feature based detection itself, as we all discussed. So this is how the feature based detection work face recognition will work. So first we have to capturing the first technique. In this technique, the foremost requirement is to capture the image that can be done by using scanning existing images or using the camera. So there is one. So while we do the biometrics, we use the scanning for biometric our fingers, right? So even for like that, we can do it for face recognition. So here we can also use cameras. And second step is extracting. Extracting is a unique facial uh, extracting unique facial data, so which is different for every person, and then extracting from the sample we have to get it. Then comparing the data is if we have a database, just like we can take an example of Aadhaar. So we have Aadhaar is a larger database, right? So if you want to match the faces in the airport, like we use this comparing technique from matching the database of Aadhaar from the face sample that we have got, and matching is the fourth step. The software decides whether the sample matches any picture in the database or not. And going to the application, facial recognition is used to detect the faces in real time for the surveillance and tracking the persons or objects. So it's actually widely used in the cameras to identify multiple appearances within one frame, such as a mobile phone, cameras, and DSLRs as well. And so Facebook also uses face recognition algorithm to detect the faces in the images and recognize them. So just like you all know, the tech is going fast, and we already got the AI cameras in our mobile phones, just like a feature. So it will track the face and then record accordingly. And in the yeah, and we also have this face unlock feature within where the phone is checks whether it's an authorized person or not. Yeah, we all know we have this PictoBlocks facial face detection application. We have extension. We have already added it to our program. So let's get to know about this. So in the face detection block, we have multiple blocks. So let's get a little explanation about them. So this analyze image from the camera or the stage block is there. So this block analyzes the image and saves the facial information locally in the local drive, which can be accessed using other blocks similar to the computer vision. So we have to run the block every time you want and analyze a new image from the camera or the stage. So actually this block will analyze only one image in particular time. So if you want to take multiple images, so we have to put this block in the forever loop. So that's how it is getting integrated. So so we'll take this, analyze the image from a camera. So if you run it once, it will only take one image sample in one particular time. So if you put a forever block or repeat block, so it will take multiple images. That's how we take a video, right? So video is nothing but it's a combination of multiple frames in a second. So 24 frames in a second, 100 frames in a second. We have FPS, right? So frame per second in a video. So that's how we are taking multiple images in a single runtime. So that's how we can use this block to analyze the image from the camera or the stage. Yeah, and also we can control the camera feed on the stage using turn on video transparency, zero transparency. You can change the following parameters of the block. So there is one more block called video transparency. So this is turn on the stage with zero transparency. We don't need to put it in a forever block because it is just a setting that we are giving the program and the while it is running. And this is the camera state off or on. So we can just get the stage into on off or on off flipped. So on is like video is presented on the program, like in this area. So if you put on, it will the video will be presented on stage, or if it's off, the video won't be presented, but the camera will analyze the face or the objects. On flipped is, so for some cameras the video might be mirrored, right? So this video feed on the stage will start getting mirrored, so have to your right hand will show the left and vice versa. So you can readjust the camera by using on flipped. The transparency is nothing but it's a parameter that makes a video translucent. So 0 is defined as the camera feed and will be shown on the stage as 100. So this is how the video will fade out completely from the stage. So you can, the 0 transparency is not something will have the video 100% visibility to the background, and if you can also reduce it to 0 or increase it to 100, or you can put it in a like 50 or 50% or 30%. The transparency of the video from the background will reduce. And then we have a get faces block. So once you have analyzed the images, you can use get faces block to get the number of faces that have been recognized from the image. For example, the image is being analyzed has 2 faces, you will get 2 faces. So maximum number of faces we'll just see. So when we get faces, and you can get this expression, for suppose we got 1 face and we have expression, we have to take only first person's face. So you can use this block of get expressions of the face, and you can adjust to get which expression, like how first face expression, second face expression, like that you can change to the number of, you can analyze 10 number of faces at a time in this PictoBlock. So the get expression of the face block exports the the expression of the selected face. If the face is selected and not detected, then it just reports null. Null is nothing but 0. The expression of the face block checks whether the selected face has a particular emotion or not. So this block will analyze the expression of the face, and if it's happy, you can just put it in the if condition. If the expression of the face 1 is happy, then proceed to the next step of the program. You can use this block like that, and if the emotion matches, the block returns to true or false, or else false. And this block, the get exposition, reports the attributes of the image. So exposition is nothing but the x coordinate of the center of the image on the stage, and y position is y coordinate of the center image on the stage. And width of the face and height of the face are also there. We can analyze the width and height of the face. Based upon that, you can tell the particular person's age, if it's a kid or if it's an elder one. So the width and height of the face are also can be taken as an input. Then we have to get the position, the landmark of the face block reports the x and y position on the selected landmark from the number 1 to 68 scale of the selected faces. So it's just similar to this one. So we will continue making the face expression detector as a tomorrow's project. So I guess I hope my I'll get a camera and I can show you the face analyzation on the stage itself. So we're gonna continue this. Okay, someone is saying my volume is very low. I'm sorry. Um, yeah, we're gonna continue making a face expression detector program tomorrow. So we have this project, the script of expression detector. So we're gonna continue making this project tomorrow. So I'm gonna wind up this session in 1 more minute. So if you have any other queries, please let me know in the chat box. I hope this session went well today. We did 4 projects, and I would like to inform you that you might receive a Google form where you have to submit your little assignments, just like a tiny Q&A, because we are not getting time here to have a interactive Q&A session, because it's a chatbot and everyone is not free to like put my text in the chatbot. So we would like to send you a Google form every day, just like a Q&A session. So you'll have options of one question, and you have to answer those and reply back. So yeah, thank you so much for your time. The next session will start in 5 minutes. So the session will be cloud computing by Bharat. So I would like to take a break from you guys. Thank you so much for attending this class. Hope tomorrow will be more exciting, because we are just slowly getting into the AI topics. So you'll get to learn a lot. Uh, so I'm gonna promise that. So thank you so much. Thank you so much for your time. Have a short break of 5 minutes, and next session will start. Thank you.
Yeah, good morning all. Welcome back to the second session of cloud computing. So, yesterday we have completed the basic of cloud computing. We still not get into the core concepts of cloud computing. So, before that, we're going to start the session. I'll just recap what we have done yesterday and then we'll start today's session. So, first, yesterday we started with what are the computers, and then what are the stages of computers, and then next we studied about what is data, what is information, what is the difference between data and information. So I'll again recap that what is data and what is information. So data is nothing but a pieces of information that before the purifying the data, so that is called data, and then once we purify the data it will become a information. And then next what we have done, we learnt about what is internet, and then we learnt about IoT. Even I took some examples for the IoT. Yes. And then next we learnt about what is cloud, how the cloud is benefited, and then slowly we deep down into the types of cloud. Yes. And then we deep down into the service models, and then I'll recap what are the types of clouds. Types of clouds primarily will be the public and private clouds, and then combination of public and private cloud we call as hybrid cloud, and we'll also have community cloud, and we also have multi-cloud. So these are the cloud models. And then cloud models, we have one more thing called service models. So I told you yesterday, service models are infrastructure as a service, software as a service. Yes, we have three service models. Now today what we'll do, we'll go into the deep of everything service models, detailed about each service model, and then we'll get some hands-on activity about this, what we have learned on these 2 days. Yes, you are ready? Okay, so let's get started. Session 2, cloud service models. So what are the three cloud service models? I told you, platform as a service, infrastructure as a service, and then software as a service. You all remember, I hope, these three are the service models we have in the cloud. Next, so yeah, I told you we have three service models: infrastructure as a service, platform as a service, and the software as a service. So when it comes to infrastructure as a service, when we go into deep of what is infrastructure as a service, let's say we have a computer. For the computer we'll have a infrastructure, right, which is nothing but CPUs, storages. Yes, these are all the infrastructure required for the computer. So what we are doing, these all infrastructure will be provided by the cloud providers. Okay, that infrastructure we are using it, the data or the virtual base, we use it to develop our own websites or develop our own applications using their infrastructure. Okay, and then coming to the platform as a service, so this platform will be like already pre-built it. Okay, where we can use that pre-built architectures and we can develop our own applications on using that architecture. So that is called platform as a service. for example, if we take any applications where if we want to develop an mobile application, what we will do, we will take for example, when we compare two applications for the same market, we have a Amazon and we have a Flipkart, for example. So those two are the big e-commerce websites, right? So what I can do, I can use that kind of architecture. Okay, that kind of architecture we can use, where already pre-built it. The cloud service providers will pre-build that architecture, where on top of that architecture we can build our own app. That is called platform as a service. Where it comes to software as a service, it is like basic thing whatever we are doing nowadays. Some are there softwares, those are only online softwares we have. So what will happen, I'm a company, okay, I'm a company, I developed an application and I deployed it in the cloud, okay, and then one more guy, he also started some more company where he want to use my software in their company. Okay, for example, one example I'll take. I'm a company where I develop chatbots. Okay, so I developed a chatbot and I deployed it in the cloud. So one more person, the company is developing a software. Okay, for something they are developing a software where they want to integrate this chatbot. So what they can do, they can use that chatbot software, put it in their software. Okay, so which is nothing but they will not develop again and again, they will just use which is already ready. That is called software as a service. So these three are the major cloud service models where we use based on the requirement of the applicant. When we go into the deep down into the every single service model, okay, so first when we go for the infrastructure as a service model, so infrastructure as a service model, we can see here we are using network of the cloud provider, and we are using virtual computers, we are also using storage. So which means as I told you with the example of computer, we use all the architecture of the computer, we use storage, we use virtual computers, we are also using networking in the infrastructure as a service. So here we can see the major characters of infrastructure is we use like whatever the architecture is developed by the cloud provider. I'm an organization, okay, so in my organization developers will use that virtual world we call VR, right? So that virtual world, the people will use that infrastructure in cloud infrastructure to develop or to work on their clouds. Okay, so the basic characters of infrastructure as a service is resource. So this when we are using what is the benefit of this means, when the company is using infrastructure cloud, they can share the resources. So we have a 10 employees in a company where in that 10 employees 7 employees are using the cloud, working on the cloud. So that one infrastructure can be shared along the 7 people, the resources will be shared along the 7 people. For example, our computers will have a RAMs, right? 6 GB RAM, 7 GB RAM, and the storages will be have 512, 1 TB. So what will happen when I'm using the cloud infrastructure? For my work, only 2 GB RAM is required, and 512 GB storage is enough. And one more guy who is also a teammate, he required 3 GB RAM, and he required around 200 GB storage. So our company bought 1 TB storage and 12 GB RAM. So what will happen? The storage capacity and the performance of RAM will be distributed along the 7 people. So when I'm using 2 GB, it's 12 GB, right? So more 10 GB is free. That 10 GB can be used by one more employee who is working along with me. So that is the major help for us when we go for the cloud. When we are using in the systems, right? When we are using the what physical systems, if I'm using one system software like which is around 12 GB, same 12 GB 1 TB, so that can be used by only one person. If the other person want to use, he also need another hardware, right, with some around one more CPU, one more monitor. These all required for him separately. So that is the major help when we go for the infrastructure as a cloud. And these infrastructure can be different types. So when we going for the subscription models, so that subscription models will have like you bought 1 GB data, so that 1 GB storage only can be used by you, or else we have one more what we called service model, that is on demand. On demand is also a one type of uses. We have subscription, on demand. Okay, these are the different types of resources. So what will happen when we are using an cloud? So initially we required only 4 GB, and then later on we want at particular time for 1 day or 2 days we required more GB. So that time we can use on demand scaling. So that is also one more help when we go for the infrastructure as a service in the cloud. For example, let's say I'm using a computer with a 6 GB RAM and 1 TB storage. So I'm developing an application. Let's say it's an AI application. So we all know AI required more storage, more capacity. So what will happen whenever 1 TB storage and 6 GB RAM is okay when I'm developing starting. So if increasing, if I want one more 2 GB of RAM and 512 GB of storage, how we can increase in our CPU? It is not possible, right? So if it possible, by adding more cores of RAM, or by adding external hardware like storage. See, we bought that storage, but later on after 2 days we don't want that storage. Normal storage 1 TB and 6 GB RAM is enough. Then what we can do with the external storage and the external RAM? That is waste of cost, right? So when it comes to the infrastructure as a cloud, whenever we required that 2 days, we can use whatever the amount of storage or whatever the amount of RAM required. Later on we can reduce the usage of storage and the RAM. That is called on demand scaling resource. That is very good model. It depends on whenever we required we can use that. And yeah, users can use single piece of hardware, like that's what only one hardware can be used when the more than 2 people, 3 people can access the same infrastructure. So that is one more useful and good thing with the infrastructure as a service. Yeah, we also have a utility based price modeling. That's what utility based means. How much we use, we'll pay for that much. Okay, we have utility based, we have on demand, and we have subscription. So utility based price modeling also will be there in infrastructure as a cloud, where how much storage or how much RAM we use, for that only we'll pay. That will not possible when we go for the physical systems. Yes, so that is a good benefit of infrastructure as a service. And let's get into the one more cloud service called platform as a service. So this platform as a service will help us like operating like what we can say, we developed an application, we want to give it for the users. So what we will do, we will use their platform. Okay, so there we can have a service, there we can have a computer. So this will help the developers or for the organization to put our software something in their platform where users can use it. Okay, that is platform as a service. For example, if we say where in that platform how it is helpful means, let's say team of 4 people are working on a one project. Okay, there is a designer, there is a developer, there is a tester, these all will be there. So when we go for the platform as a service, what will happen, there will be a single environment where we can design the software, where we can develop the software, and also where we can deploy the software. So there will be only single environment, we can do all these things. When we develop the application offline, like in our own storage, what will happen, we need to develop it on the offline, and again we need to deploy there, we need to maintain the external. Yes, so when it comes to cloud, we can develop, deploy, okay, we can test, and we can also maintain the software only in a single platform. Okay, so there is a good thing called where when we are developing an website or when we are developing an application, UI is a major thing which gives more users. Okay, backend is a one thing, what for what thing we are using, what technology is developing, what features we kept is a 50%. The another 50% is how attractive the application is. Okay, and how interactive, how easy the users can use it, right? So this platform as a service, okay, this web based UI designing, where we can create our UI in the platform. Okay, so we have one more thing called see, wherever we are maintaining the application, the major thing is users will not be same for the every time. For example, if we take an Hotstar, okay, in that Hotstar regular users, if we take 4 million, whenever something is streaming like cricket or something live is streaming, the users will increase at a time, and the later on once the live is done, the users will reduce. So the load on the software, the load of users will be different. Okay, so that is called load balancing. That load balancing, what we need to balance the load, we need more storage and more performance. For that performance we need more RAM. So what the cloud platform will have, once we deploy our application there, that platform, if the users increase for our app, it will balance it at that particular time. It will increase the storage and it will also increase the RAM. Once the users are reduced, again it will reduce the storage and the RAM. So that is how it will balance their load. And the next, if we see, security is more when we go for cloud services rather than when we deploy it from the offline, like physical thing. So that is a one more advantage of this platform as a service. Yeah, so when we use the platform as a service, the tools or the softwares whatever we are developing and we are putting in there, the software automatically have everything like subscriptions or everything will be taken care of that platform. And next comes into the software as a service. So these three services will be in a structure of pyramid. Okay, infrastructure will be on the bottom, and the platform will be on the middle, and the next comes to the application. So this is how the architecture will be there, that is in the pyramid form. This application as a software as a service, okay, that we call as topmost layer in the service models. Okay, we call as SaaS. What we call as SaaS. SaaS is nothing but software as a service. This cloud service is, for example, it's just like a opening platform using it. Okay, for example, if we take clouds, okay, we are taking any application which is deployed in the cloud. It's just like users will open that application, users will just use that application and will leave. Okay, so that is the top layer of the cloud services. So it is certainly it looks like a company which is using a software. Okay, the company can access the software, use the software and leave it. Okay, so that is the three layers of cloud services. And here if you see, there will be a different user for the different cloud service. Okay, so infrastructure as a cloud service, okay, platform as a service, and software as a service. So I'll tell you who will use what, as I explained with examples, lot of examples I took for every this thing. So infrastructure as a service will be used by the IT professionals, okay, where they do the applications, okay, where they can customize the applications. Okay, so this is the bottommost layer, where if you take a company, there will be a three different layers will be there when we are developing an application, right? The topmost layer will be the user, the next comes to the tester, next developer, next designer. So this is how the chain will be. So this same thing will happen in the services. So infrastructure as a service will be used by the IT professionals, where they can develop or deploy these things. And next comes to this thing, what we call platform as a service. Okay, this platform as a service will be used by the developers. What is meant by platform? There is some base, okay, where we use that base to develop our own application or something, app or website. Okay, that is called the platform as a service. So what developers will do, there will be a platform where they will develop an apps, or they will develop an applications, websites for their organization. Not only developing, what we can do, we can use other softwares where we can customize those things. See, we have two companies which are working for the same field. There are only some features need to be changed. So if we want to develop from the scratch, it will cost more. So what we can do, we can take that architecture, that software, and we can customize it. Okay, that software development can be done by the developers on the platform as a service. And the last and topmost service is software as a service. So this software as a service is deployed in the cloud because to make it speed. Okay, that's what I told you, right? For example of Hotstar, if the users increases, the app will be slow down. When it is in the cloud, okay, we have on-demand services whenever the users increases, the same amount of required storage and the RAM will be increased, so that the speed will not be reduced, the speed will be same. Okay, this software as a service will be used by the end users, we call as business end users. So these are the three services, and these are the users are different for the different services. So we see a few cloud services, the big major cloud services we can say Salesforce, Google Cloud, Azure, IBM, Oracle, Amazon. So these are the major cloud providers. So these cloud providers or same services will be provided, but the different is the prices and the architectures are different, and the what we can say the different architecture will be given by the different providers. Okay, so these are the cloud providers. So okay, so I hope you got these points. If you have any doubts, I'll give 5 minutes. Just ask your doubts in the chat box. I'll wait for 5 minutes. Okay, I hope you don't have any doubts. I think you are mastered. You are on top of lecture. Okay. So next, what we'll do, we will do an activity on these two lectures. Okay. So before that, I'll brief whatever I taught you from yesterday. Okay. So what the first I will teach you, I'll recap you whatever once again whatever we have done from the yesterday. Okay, so we learnt about computers, we learnt about data, we learnt about information, we learnt about internet. Okay, and then we jumped into the what is cloud, what are the cloud services, what are the cloud models, and then now we have completed what are the cloud services, who will use the what cloud services. Okay, so we have 3 cloud services. Okay, and then we saw that a few cloud providers, those are Amazon, Google, Azure, Salesforce, and Oracle, IBM. So these are the major big cloud providers. So next we'll go into the activity. So So that activity I'll explain you what you need to do that activity. So I hope you'll follow this. Okay. So group activity. So we'll not do group activity. We'll do a individual activity. Okay. So what you need to do, you just need to create a simple presentation on benefits of cloud computing. So not exactly on only on the benefits of cloud computing. I'll explain you what you have to do. Please do that that presentation. Okay. So what you need to do, I gave some instructions. You need to whatever the instructions are there, you need to follow in the presentations. So you need to choose one platform where you want to develop an presentation. That can be different things, Google Slides, you can use PowerPoint, you can use Canva, or else if you know other what we can say presentation developers, you can use that platforms as well. And the major thing you need to do is just pick up a topic. Okay, you just pick up a topic, start researching on it. I'll show you how to research on it as well. So not only this topic, I'll show you whatever the topics are given, how to research. I'll show you now. So you need to just understand the key concept of the research. When we are doing research, you just keep your pen and paper side, and you have to note down what are the understanding from the research. So whatever the things, what are the benefits, what are the advantages, what are the disadvantages, what are the different providers, or whatever the topic you choose, and based on that you need to note down the understanding key concept, and then you have to organize your presentation. Okay, you have to organize your presentation, note down these things. These 5 things has to be in the presentation. Okay, introduction, what are the benefits, types of cloud, and the examples and the conclusion. These things must and should you have to keep in your presentations. Okay, so let's get I'll show you how to research it. Please follow me. You just open the Google and type Google Scholar. Okay, once you type your Google Scholar, just open that first link. Okay, once you open the first link, you need to write a keywords. For example, we have, okay, see, I just typed a cloud, so we are getting different types of whatever related to the cloud. So we'll click on cloud computing. So these are all the research papers already done. Okay, these are all the research papers. So we can just customize here. We want from 2019 to 2024. So papers will be given only from 2019 to 2024. So I'll show you what you need to do. So not every paper will open. There are some paid papers that will not open for us. So this is the paper title. Okay, and beside that you will have these kind of links. So once you click on these links, the paper will open. Yeah, the paper will open. So if once you open the paper, you just need to read that paper. So I'll show you what we are doing now. So we are doing cloud computing services, right? We are doing the activity on cloud service act. So here we'll give customized years from where to where we want. So once we give these things, so we'll get all these things, right? So just choose one topic, whatever the topic you choose, you just type here, you can get that. See here, infrastructure as a service clouds, okay, software as a service cloud. So these all things you can just type it. So I'll take here software as a service. So once we click on that, okay, once we click on that, you can just open some paper like software as a service, cloud computing, empirical investigation on, okay. So this thing, I'll open this paper. So what you need to do, once you open the paper, you just read the title, what exactly the title is. You just understand the concept, what the paper is going to tell us. The first thing you need to read is this. So you have to read the abstract. Once you read the abstract, you will get the overview of the paper. It's waste of time reading the total paper. Just read the abstract, you will get to know overview of the paper. So here this paper tells us about just 2 minutes, I'll read this paper. Okay, so this paper telling us about it's a foundation or some school. They want to develop a software where the students and teachers will be on the same platform, so where students can get the materials, whatever the materials uploaded by the teachers. It's very easy to communicate that. So it is like a e-learning platform. So they want to use the cloud service for the e-learning platform. So if we think this is useful, we can just go through this. Okay, we'll just go through this. So here you can see this is all introduction. So this is the methodology, how they build the software, what type of architectures they used. So these all things will be given here. So this is the flow diagram of the application. So this is how you need to read every step by step. Okay, so this is what they can give access to the mobile phones, systems, laptop, computers. So these are the things users can use, open that application. So this is architecture, how it will be like. So these are the users. Okay, this is the application software, these are the databases. In that databases it will be different. So I think you know database, how the database is. So the database will be different types. It can be in the table forms, it can be in a what we called paragraphs or key points. So key value page we call that. So in that way it will be different. That is not our topic. So the databases will be there. So these databases will store the data. These are different users, right? So the different users data will be stored in a different data, like data frame. So these databases are interlinked. So whenever the other user want to use the software, this interlinked signals will be given, the fetch the data and given to the user. So basically this is what the paper is about in software. So using SaaS. So this is a platform what they want to build using the cloud. So this if we built on the cloud, what will happen? Everything will be run on the cloud. Nothing, what we called pressure will not be given to your physical system. Everything will be run in the cloud. So this is how we need to read the paper. And the last you need to read the conclusion. Okay, so once you read this conclusion, you will get to know how much they develop, what else they can do it. So there will be a called future, what we can do in the future. So that is how conclusion will be, what they develop, what can be done in the future. So you need to read till here. Not only this paper, I am just telling what you can do, how you can do. So once you read this paper, you'll get to know all the information, right? So in this, take that information, whatever I told you here, right? Introduction. In the introduction, you need to include, right, what paper you are using, okay, on what topic you are doing the presentation, and then next benefit. So the benefit is like, for example, past paper what I took, right? So the benefit is they are building an application for the teachers and the students. So there are some benefits of e-learning material will be given. It is very easy access. So these kind of benefits will be there. So you need to write that benefit. And the type of cloud means what type of cloud. See, if we see that past paper, they are using SaaS. So what type of cloud they are using, okay. And then next, some examples what you have seen in that paper. And then next you need to write conclusion. So this is what you need to include in the presentation. Not only this, okay, you can also do it another way. Not only doing these papers, you can also do it in another way. You can just open the Google and search for that, what we can say, okay. So now we want to write about one product. Okay, we want to write about one product. So what we will do, we will write about one product. We will write about one product using one cloud service. Okay, we will write SaaS product. So we'll just open that few links. You can just go through that links. So you can just find there. Okay, so what is that? What actually the SaaS product is? What is SaaS product? Okay, you can read these all things. These all the products developed by the SaaS, which is Google Apps, Dropbox, Canva, free logo creators. These are all the products built by the SaaS. So you just read this about the SaaS product. Yes, you have a key features of SaaS product, benefit of it, okay, so drawbacks. So you have everything here, right? You just read this, okay. Once you read this, obviously you can get these all things, yeah. So this is the thing you need to do. You just first choose a platform where you need to develop a presentation, and just first choose the topic, what topic you want to do, research on the topic in the way how I told you, right? We have two types of research we can do. We can do from the Google Scholar, or we can directly do from the Google. So these two can be done. Once you done these two things, you just write, introduce these all things in the presentation. Okay, so I hope you will do these things. Yeah, we have I think more 40 minutes, I think 40, yeah. So just give a chat that will you do it. Type it in the chat, will you do it? or else should I give it as a homework, or where you can do it after the class? Just please respond in the chat. If you respond based on your responses, I can do what you want to. Like, we need some interaction, what you are doing, what you want to do, not only what I am telling you are listening. That is not the case. Please respond in the chat. I'll give 5 minutes. Yeah, you want to do this activity, or you want to continue with the lecture? Okay, I hope you are not responding. So you're not active, I think. Okay. Yeah, we'll continue the lecture. So we have completed what are the services provided by the cloud, but we have one more thing called cloud storage. Okay, now till now we briefed about what are the services, who are the service providers, this thing. So now we'll step by step we'll go into the deep of every single concept in the cloud. So now in this thing I'll tell you about the cloud services. Okay, what are the cloud storages, who are the cloud storage providers? Yeah, so cloud storage means we have a data, we want to store it. Okay, so what we are doing, we are not storing data in our physical devices, we are storing the data in network. Yeah, network means we are storing the data in someone else storage. Okay, so let's say we are the company. Okay, we developed an application, or we have a 1 TB of data. If we are storing in our own company, if something happened in a company, our data will lose. So for that, what we are doing, we are saving our data in someone else storage. Okay, that is called cloud computing. In that cloud computing, this is the data storing is called cloud storage. Okay, so that is called storing in the digital data. Yeah, so let's see history of storage systems. And the storage system started in the 1881. So in that 1881, first storage system is punch cards, and then later on we got it magnetic tapes. We see that it looks like reels. Yeah, so where the if we take a photographs, so we will get in the black and white reels kind of things, that is tapes. And then we have hard drives. Okay, next we got discs, and we got into the 1983. In 1983 we got a CDs, DVD CDs, and then next we got into the SD cards. In 1990s, we got a SD cards, and then next in 2000s, starting of 2000s, we got a USB. Now, from 2012 or end of 2012 or 2013, we got a new storage called hyperclouds. Okay, hyperclouds is nothing but, see, these all storages are very less. See, this is very big, but the storage is less. And then later on, what is happening? The device size is decreasing, and the storage capacity we are increasing. Okay, nowadays most of the people are using cloud. For example, in the past olden days, what we did, we took a photos with the camera, or we took a photos with something. We'll store it in the photographs, or we'll physical copies, or we'll store it in the mobile phones. Next, later on, we used to store it in the CDs, and when in 1990s or 2000s, we used to store the data in the SD cards and pen drives. Now, from 2013, the people are converting their storage into the cloud. For example, we have a Google Photos. Okay, so what we are doing, we are not storing our photos in our mobile phones. We are storing our photos in Google. So if we change our mobile phone also, photos will be safe. Yes. So that is the reason the people are converting into the cloud storage. So this is the history of cloud storage. This basic history of cloud storage. What we call storage systems. Nowadays, people are using cloud, and I told you in the few minutes back. We see few cloud providers like Amazon, Google, okay, IBM. Yeah, we see a lot of things, right? So for every Google provider, Google cloud providers, for every cloud provider they will have a cloud storage. They will give a service cloud storage, right? So iCloud, OneDrive, Google Drive, we have a cloud, Amazon, we have a cloud drive, we have a Dropbox, which is given from IBM. Yeah, we have a Ice Drive. These all the storage services given by each cloud provider. We have different cloud providers. Every cloud storage is related to their respective cloud providers. Yeah, these are the we are aware of, most of the people are aware of, I think, Google Drives. So this is given by the Google. So this Dropbox also very popular. OneDrive is very popular. Very iPhone users or Apple users will use iCloud, which is only they will give for the iPhones, Apple products. So that is iCloud. Yeah, this. So the major difference is this is related to their own cloud providers, and also there will be a difference between the every storage service. So Google will give up to 15 GB, one more will give up to 1 GB, 2 GB, and there are some cloud storage providers, they will give only free access for the students, free access for the citizens. So the services will be different, the architectures and the type of services given by the storage is different, but at the end all are related to the storages which are storing in the cloud. I hope till now you understand this topic, and we'll move forward. Yeah, so here there are a lot of cloud storage services, right? So here from these storage services I'll choose one or two storage service, and I'll explain when it is developed, from whom it is developed, and I'll explain what is the type of services the storage is provided by different providers. So let's go into the deep of briefing of every service. So if we go for this Google Drives, so Google Drives is produced by Google. Yeah, we have a Google Cloud. That Google Cloud maintains the Google Drives. So this product is developed in 2012. I told you cloud came into the picture from end of the 2012 or 2013 starting. So these Google Drives will help us to store our files. It is very fast. Okay, so your objects or your documents, everything, whatever the type of file you want to save, you can save in the Google Drive. So coming into the what are the what we can save in the Google Drives is we can save audios, we can save videos, we can save documents, we can save images, we can save Excels, we can save PDFs. So these we can see here, like, yes, so these all things can be stored in the Google Drives. But the thing is, there are some different things in the Google Drive. So this Google Drive starting storage is 15 GB. Every Google user, every Gmail, if you have a Gmail, you can get up to 15 GB free storage. Will not get 1 GB, 2 GB storages. Only the minimum basic storage is 15 GB. Yeah. So here you can keep your pictures, stories, designings, records, videos. So file restrictions are not there. Okay, file restrictions are not there. You can save whatever you want, you can save it, but the minimum storage capacity is 15 GB. Yeah. And next we'll go for this Dropbox. So this Dropbox is different from the Google. So this Dropbox is developed in 2007 by MIT some graduates. So this Dropbox, it starts from MBs only, but the thing is till only 2 GB the storage is free for the Dropbox. If the storage is increased by 2 GB, you need to pay for the storage. Okay, so this is like we can open this Dropbox from mobiles, from laptops, from desktops, everywhere we can use this Dropbox, where we can share the same files, like what we can say, we can save photos, we can save videos, we can save. So the features are same, which means the file storages types are same, but the difference is what type of like 2 GB, only till 2 GB you have free here, where it comes to Google we have 15 GB free. Yeah. So the architecture, if you see, of Dropbox, so the users can be used from the desktop, from the web, and from mobile, and you have a cloud between user and the storage. So you can just see this architecture. I'll keep it for some time. I'll just brief about how the architecture works. Once you just see this for 2 minutes, I'll explain how this architecture works. Yeah, I hope you observed the architecture. So I'll explain you how this architecture works. So when the users are using through the cloud, so the thing is, the storage is a backend, but to access that storage we need to access from the cloud. So in between storage and the client will have a cloud. So what the cloud will do, whatever the information, whatever the retrieving of data or storing of data will be given to the block servers. So these block servers, what they will do, they will divide the data into pieces. Okay, so that pieces data will be given to the load balancer, because whenever the users are increasing, the load on the cloud will be increased. So what the load balancer will do, it will balance the load of the users. If the users are increased, it will balance. If the users are reduced also, it will work same. So it is not about how many users are using, the fast will be same. So from that load balancer, the data will be given to the meta services. So these meta services, servers, what it will do, it will store the data. These block servers will give the data to the cloud storage. So whatever the retrieving or uploading of data given by the client to the cloud, from the cloud it will take the block servers, from the block server it will store it in the cloud storage. So when we are going from the users to the storage, we have few mediators, so we'll not have a direct access to the cloud. Okay, so this is the architecture of the Dropbox cloud storage. So why meta servers are used means, if we are using a big amount of data, so when we are using a individual data, it is only up to 1 GB, 2 GB, might be a 50 GB, 100 GB. But when we are going for a organization data, it will be in the more data, right? It will be in 10 TB, 100 TB, yeah, gigabytes, it will be more. So what the meta servers will do, when the data is increased, yes, the data is increased, which means the users of the data will also increased. So if you take an example of an organization, only one person will not use that data. So many people, when we are developing an example of application, 7 to 8 people are using it. So that 7 to 8 people will retrieve the data, upload the data, retrieve the data, upload the data. So which means the loop will be there. So when the people are increasing using of the data, so the load will be increased. So to reduce that thing, we use meta servers. Okay, so this is called architecture of Dropbox. So this is developed by MITians. The features are same. We can store what type of files we want, we can store it. But the thing is, I told you, the architecture will be different and the storage capacity will be different. Here for the Dropbox we have only till 2 GB free. When it comes to Google, we have 15 GB free. Yeah, these are the two things I want to explain you about the detail of cloud storages. So again I'll brief you. So these are the popular cloud storages: Google, iCloud, OneDrive, Dropbox, Amazon Cloud Drives. So these are the cloud storage services, and this is the detail about the Google, and this is the detail about the Dropbox. Yeah, I hope you are clear about what are cloud storages, architecture of cloud storages. Yeah, I hope you are clear about it. So once again, I'll recap today's lecture, what we have done. We started with the cloud service models. Yeah, in this cloud service models, we covered 3 types of cloud service models. So this cloud service model is in the form of pyramid. Okay, software as a service will be on top of, and the infrastructure as a service will be on the bottom, and the middle step will be the platform as a service. So we went in detail of these 3 cloud services, and we also learned about who are the users of what type of cloud, Yes, we saw this. Who uses the infrastructure, who uses the platform, who uses the software, and we learned about who are the cloud providers. These are the cloud providers: IBM, Azure, Google, Amazon, Salesforce, Oracle. These are the cloud providers. Yes, remember this. These are the cloud providers. And then we I have given some activity for you. I hope for tomorrow, by tomorrow session, you'll complete this activity. In this activity, I'll again recap it. So you need to create an presentation. Okay, you need to create an presentation by researching on the topic of three different services, or three different types of cloud. So I told you public cloud, private cloud, hybrid cloud. You can do in that as well. You have a community cloud, you have a multi cloud. So you can do research on those topics, or else you can do research on these services. So I hope you remember what are the things you need to include in this presentation. Yeah, we learnt about this, and then we entered into the introduction to the cloud storages. So in this introduction to cloud storages, we learnt about what are the cloud storages, and we learnt about history of storages, how the storage started with the punch cards in 1881, and then later on now we are using the hyper clouds. And then next we talked about popular cloud storages. First I showed you popular cloud providers, that every cloud provider have their own cloud storage. These are the cloud storages. And then I told you about brief about what is a Google Drive, yeah, how it is used, what are the things can be done in the Google Drive. And then I told you features of Google Drive, and we went into the about the Dropbox. What is Dropbox? Architecture of Dropbox. Yeah. I hope till now you understand about these things. So now it's time for Q&A. So please, any question, if you have any question from yesterday class or today class, please feel free to ask me. I'm open to clear your doubts. Yeah, just keep it in the chat box, please. Ask your questions. Waiting for your question, please. Whatever the question, no problem. It can be a small question, it can be a big question, it doesn't matter. Don't feel anything, just start asking questions, so that not only you, the people who are afraid of asking questions also will learn. So you got the doubt, someone may not got the doubt, they'll also know about the things. Please try to ask your questions. At least if you have no questions, please say no questions. At least I'll have a clarity on you, at least you are there or not. I don't know how many people are there. If you have questions, at least ask questions. If no questions, at least say no questions. No doubts. Okay, no questions. All clear about the activity? No questions at least about the activity? Okay, everyone is saying that no questions. Yeah. I hope you will do the activity after the class, after the sessions are done. Please do that activity so that you will get to know more deep about the detailed about the services or the models. So when you're doing the practical things, you will get to know more things. So please do that. So tomorrow I hope you'll complete by tomorrow. Yeah, I think we are done with the session. So if you have no questions, I'll wind up the session. I'll wait for more 2 minutes. So if you have no questions, I'll wind up the questions. Okay, I think we are done. There is no questions. More than 1 minute, I'll wait. If you have any questions, please ask. Okay, I'm winding the session. Thank you for being in the session and listening. So we'll meet tomorrow. Bye bye.
So, hello, good afternoon, everybody. I hope you all are back from your lunch breaks. We'll just take a minute so that you'll settle down and we'll start off with the session. And I hope I'm audible. I request you all to put put the messages in the live chat so that I can see if I'm audible or not. So I hope I'm audible. Please let me know. Just one or two messages would be great. If I'm audible, I will be continuing with the sessions. So yesterday I have given you a small task. It was to come up with an activity for making the concept of decentralization even more clear. So I really hope some of you has come up with the same. So if so, please put it in the chat box if you have come up with something like that. But volume is very low. Okay. So I'll try to be louder, and I hope now it is clear enough. Yeah. Please let me know if I'm clear enough so that I will start off with my sessions. Yeah. Okay. Okay, I'll start off with the session. So today's topic is explaining blocks and chains. In the before sessions we have discussed what is a blockchain, of course, but then how are they connected? What are they individually? How is it even we are calling it a blockchain? So that we are going to learn today in this session. So let's start off with it. So, what is a block? Blocks are the basic units of data storage in a blockchain. So, they contain information about the transaction along with some other important data. So, what might be this data? This data is nothing but who's the sender, who's the receiver, what is the data. So, this block contains all the things which happen while a transaction or data is transferred. So, in that, it can be the sender information, it can be the receiver's information. Just give me a minute. Yeah. Yeah. It can be the sender's information, receiver's information, the data which you have shared, what is the amount of data you have shared, and let's say amount in the sense what is the storage, that is maybe 200 MB, 1 GB, what is the data you have shared. So that comes under this blocks. Yeah. Yeah. Yeah, that's fine. Okay, so sorry for the interruption. We'll continue. So, yeah, understanding blocks in blockchain, that's what our topic is. And in this blocks, each block contains one set of information. Let's say I make a single transaction. Hundreds of transactions are coming into one single block, but then what does that block contain? What type of information that block contain? What is the structure? That is what we are going to learn today. So, structure of a block. There are three things: header, transaction, and hash. So, let's have a quick reading about it so that we'll understand what all are actually present in the header. In this, so header, that contains the metadata, that is the original data about the block, like what is the block number or the unique ID which the block has, and its version. Let's say, of course, everything needs an upgradation, what version it is in, and its timestamp. So let's say you made a transaction at around 2 p.m. and at 45 seconds. So 2 p.m. 45 seconds, so that timestamp with the seconds, because that is very much necessary when you want to, when you need the information part, and the reference to the previous block. So this previous block is called as hash pointer. So why do you think we need a reference of the hash pointer, like why do we need something with the previous block? So here the reason is, let's say we are creating a blockchain and all the blocks are connected. So when all are connected, we need to know which is the first, and we need to know the reference. Yeah. So we need to know how the blocks are connected, and we need to know if it's in series. We need to know if it's related to the other one. So let's take an example of a bank account transactions. So I would say May, April, June, like all these months, right? So each month is a block, and everybody should know, like let's say the transactions that happened in May in a bank account. So I mean to say is that it needs to have an address telling that it's my account or it's your account, like a particular person's account. We need to have that information. So this hash pointer helps us, go through this and identify that it's the, like the address, to understand it. And the second part is the transactions. These are the actual data stored within the block, representing actions or exchanges of value. So let's say, as we were talking, how much data it'll be having and all, right? So it's of course it's the data. The header will have only the metadata of the block, about the block. But then in transaction part, as the block is divided into 3, in the transaction part, we will also have the original data and the amount of data. I mean to say, like how much GB you have been transferred, or let's say if we talk about in the point of transaction, it's the amount you have been sending, and it also represents the exchange of values. That's what it represents. And the third one of the structure is hash. So we have already discussed about hash before. I'm so sorry, just give me a minute. Decrease the volume. Decrease. Yeah, we will continue. So hash, it's a unique identifier generated by applying a cryptographic hash function. Okay.
Move a little forward then.
Okay, I'm so sorry, there was a small interruption. We will continue. Yeah. Yeah. Great. Okay. I think this is fine. Okay. Perfect. Yeah, thank you so much. Yeah. So we will continue. The third part of the block is hash. It is a unique identifier generated by applying cryptographic hash function. So this is nothing but it is used to generate a mixture of unique numbers. So it cannot be any other number. It should be the identifier. So it makes a lot of calculations together to find to make this unique ID to recognize that block. So this this hash has this its its function is to put the security, and we already discussed about a topic called immutability. So as we know, immutability is nothing but once a data is entered, it cannot be changed. So it's similar to this. So this hash, that number, it is the one which is responsible to ensure that the data is not changed, because the unique ID which has particular data saved in it, and you can never change it, and that is what ensures its integrity. So now that we know the structure of a block, let's go deep into it to understand it even better. Yeah. So here, components of a block, as we were discussing: header, transaction, hash. Please make a note of it so that we will be requiring this in whenever we make a blockchain. So the header, it is the topmost section in a block. In that section, the metadata of the version, like which type of version block data you're sending, or what is the timestamp. Nouns, let's say I am sending some information from one blockchain to another. So nouns is nothing but the address which the other blockchain holds. So if once I send some or transfer some data, I need to know from where it came, right? So this and nouns will have this capacity or the value to understand from which blockchain the thing has come. And next is Merkle root. It is nothing but the encrypted data. Encrypted version of the address, because as we were discussing yesterday, to ensure security, we encrypt the data and only the receiver and the sender will understand. So this Merkle root is the encrypted data of that address of other blockchain. And the previous block hash we have already discussed. When a blockchain is connected to the other, the next one, so let's say 0, 1, 2, 3. So the 2 will contain information about 1, telling that it is a continuous block and these blocks are related. So the previous block hash indicates that address. And I hope you all are following. If so, just put something in the chat box. Yeah. I'll meanwhile continue. So the transaction, the actual data stored. So speaking of which, of the security, of the transparency which we were discussing yesterday, this actual data cannot be visible to other people in the blockchain. I mean in the other blockchains. Only that group will be able to access the data and nobody can change it even though they are able to see it. So we can say that the transactions or the transaction part where the data contains is kind of hidden and it's secure. So in this transaction part, the actual data is stored, of course, and the exchange value, let's say it's a normal transaction, then it will be the amount. Let's say you're sharing some data, then it will be like it will be the data amount whatever you have been sharing. And it also contains the sender, receiver's address, or the name or from where it came, and also other relevant details if it's a data. And then the third part is hash. It is the unique identifier. As we were already discussing, each block has its own number. So this hash will be carry forwarded to the next block, where this value will be stored in the header of the next block. So I hope you're understanding the chain, how it works. So my hash in the 0 block will be the header for the first block. So 0, 1, 2, 3, right? So that is how it works. So in this hash, it's we apply a function. It's a combination of many calculations which will ensure a unique ID for the single block, and it is responsible to detect even if one block is changed. Let's say we are adding something in the blockchain. As we know, it is immutable and nobody can change it. And if somebody is trying to actually change the data, the hash will identify immediately, because it has the same hash number but the data is changing. So that is how it works. We'll move on to the next part, transaction. So as we were discussing yesterday about digital transactions, why do we need digital transactions and what are they? So let's come to transactions in a block. Transactions are nothing but exchange of data or digital assets. So what might be these digital assets? They can be cryptocurrency. So if you can share a Bitcoin, like if you want to send money to somebody else through Bitcoin, you can pay through Bitcoin. So transactions are exchanges of digital assets or data. It's like sending cryptocurrency or recording ownership. So let's say, where can we use blockchains in real life? Maybe let's say we have a part of a big land and each land is divided into blocks. So if they are divided into blocks, with using blockchain technology, we can make sure nobody else will come and take your land. Like it's secure in their name, and the ownership is perfect. As it's already, all the details are already taken, and nobody can change it. So they are they're together. So all the data will be together. So again, coming back to the point, what is a transaction again? Transaction represents actions within a blockchain network such as sending cryptocurrency, recording ownership, or executing smart contracts. We have a big topic called smart contracts where we will discuss very deeply about it, and we have many case studies about it as well. So when we move forward, we'll learn about them. But initially, cryptocurrencies are nothing but the bitcoins, ether, ethereum. There are many type of cryptocurrencies, right? So of course they can be used as, they hold some value, so they can be used as a part of exchange. That is a digital currency. So let's move forward and understand it in a better way, including transactions in a block. So we know what is a transaction, we knew what is a digital transaction, why do we need secure digital transaction, and so on. But then here we need to understand how to include, I mean, how is this even related? What are blocks? How is it related to the transactions we make? How do we include that transaction into blocks? And how are all these linked together? So in this topic that will be going on. So here blocks contain multiple transactions grouped together, forming a chronological chain of verified and immutable records in the blockchain. So blocks contain multiple transactions. Let's say I'll just again take the same example of a bank account, and let's say I have months: January, February, March, April, and so on. So all my January transactions are completely grouped and made into one single block, and all my February transactions are made into another block and kept in one single another different block. But the thing is, they all are connected because my February will have the header of January, of the hash of the January, so that they are linked and telling that they represent my account, and all these are connected into a chronological chain. And it's verified and immutable because once your transaction is made, you cannot go back and change the thing in what we say. You cannot change it in other months. Like once it's done, it's done. It's immutable. So that is what keeps it linked, and you cannot, once you change it, if you try to change it, or if somebody tries to change it, they are simply caught. And the next part is how to link these transactions with blocks. Transactions are linked to specific blocks through cryptographic mechanisms, ensuring their order, integrity, and immutability within the blockchain. So here it means, let's say, as we were speaking about one single topic like bank accounts, there are many other out there. So all the specific blocks which are need to be linked together, they will be linked. In, like, let's say, as I was talking about the bank accounts again. So these cryptographic mechanisms are nothing but the calculations or the unique ID which we generate to keep it secure. So of course, and everything is in order to understand line by line transactions. So it is kept in order. Let's say if it starts with 0, 0, 1, 2, 3, that's how it is going to go on. So now we know how to include this transaction in a block. Like we can group all together and put one there, right? So it's not like one single piece of data will be in one single block. No, hundreds, millions of data will be in one single block. Okay, so let's keep going. What are these blocks and chains? Coming back to this point, yesterday we learned what is a blockchain. We kind of understood what it is. But now we need to know better about how are these connected, what are they separately, and what are they together. So first point is connecting blocks. Blocks are linked together in a linear sequence, forming a chain. So whenever somebody asks how, or whenever there's a question how blockchains are connected, it should always be, the answer should be linear sequence. So it goes on in a line, it's connected linearly, so one after the other. they form because it's connected one after the other, they form it like a chain, and it's not the sequence will be linear, and each block contains the reference of the previous block hash, so it's interconnected. That is the reason we call it as what we say that's the reason we call it as a chain, and they are linked together. That is how we are able to form a chain. That's a perfect example we can take, right? And the next is, what is the structure of our chain? A blockchain is structured as a series of interconnected blocks. So let's say the one big block, it has many other blocks which are connected internally, and again another block which has things connected internally, and both together make a one big blockchain. So it's like it's in series. Again, as I told, it's 0 1 2 3, or A B C, and it goes on. And let's say in A there is A to Z, or 1 to 10, or 1 to 100, and in B there's again 1 to 100, but A and B are connected again. So I hope you got how a blockchain is actually connected. And each block holds the transactional data and reference that preceding the block's hash. So of course, as we were speaking before, that how blocks are connected, they have their hash, they have what we say, the data of the previous block. Next, importance of linking blocks. Why should we even link these blocks? What is the need of this? Let's say we just put the data in each block and just leave it like that, right? But why are we trying to link them? Linking blocks ensure the integrity and immutability. Let's say I just put some set of things in a box, and I can change it whenever I want. I can remove it, I can interchange it according to me. But if they are linked, if the other block has this address of the previous block, like that is something information about the previous block, what was the data present in the previous block, it is very easy to identify. And that is what again comes that is where immutability comes into action, and it ensures that no data has been changed or removed. So that is, this is the main reason why these blocks needs to be linked, and that is the main reason where when each block has the header and hash of other blocks. So let's just have a quick reading. Linking block ensures the integrity and immutability of a blockchain, as an alteration to a single block would disrupt the entire chain's consistency and validity. So if one, let's say all these are connected together, if one is changed or one is disturbed, the whole chain will get disrupted, because each block has the data about the previous block. So if I change something in one block, the data which is stored in the other block gets disturbed immediately, right? So that is the reason the data is safe, and that's the reason they should be linked. So let's move on and see how chains are formed. So of course it's like a basic thing, but let's read it once. Chains are formed by adding blocks sequentially. As we were talking about the structure of the blockchain, it is always linear. And when we talk about linear, and also it's sequential, like it's interconnected blocks in a sequence. Yeah, we are live, right? Yeah, great. So there was a small power cut here, and that is the reason it was lost. I hope I am audible now. Please let me know. Yeah, please let me know if I'm audible and clear. Just let me know in your comment sections, and I will move forward. Just one or two, please. No, I'm just waiting, like if I'm audible or not. Just wanted to check. I hope I'm audible. Please let me know in the comment section. Meanwhile, I'll just proceed with where we stopped so that it's not interrupted. I really hope you all are there, and please let me know if I am audible, visible, and the live stream is going on. Okay, so I'll start off with it. I think I should. Please let me know. Yeah. So we finished about including and linking these blocks, right? So we were right here. Why should we link these blocks? So that is where we had ended. So how chains are formed? Every chain has one starting thing that is called the genesis block. Yes, it's audible. Thank you so much. Yeah, genesis block is nothing but the block which is the leading block, which is the first block. The first block in a blockchain is nothing but a genesis block. So let's have a reading once. Chains are formed by adding blocks sequentially, starting with the genesis block and linking each subsequent block to the previous one. So genesis block is nothing but the first block in the blockchain, serving the foundation. Like, let's say that is like the foundation in a building, and genesis block is the starting block. So I want to ask a question to y'all that, do you think the genesis block will contain the information about all the other blocks? So that's my question. I want y'all to take a minute and just answer this question, that if genesis block will contain the information about all the other blocks. Please put it in the chat box. That is a very important question to know, so that I will answer it accordingly. But before that, I'm going on to the next topic, but I want your answers in the chat box so that we can get back. Adding blocks sequentially. So blocks are added one after another in a linear fashion, ensuring the chronological order. So what is this chronological order again? It's nothing but 0, 1, 2, 3, 4. So it's in series. It's in a perfect sequence. So blocks are added one after another in a linear fashion. That's what we have learned about blockchains initially. So as my question is again, does genesis block contain the information about the previous blocks? That's my question. I request your answers so that I can move on to the next one as well. I'll just take a minute. Please let me know. Please put it in the comment section. Genesis block is nothing but the first block. So yes, so you think genesis block will have details of all the other blocks formed? The answer is no. The genesis block does not have the information about all the other blocks, because genesis block will have a header and a hash, but it cannot store any header in it, right? Because there is no previous block there. That is the reason genesis block will not have the information about all the other blocks, but it has a sequence with which you can identify and get back to that point. So genesis block will not have the information of the other blocks at all. When we form a chain, this genesis block is the foundation, of course. It will have the address of the whole blockchain, addressing the whole blockchain. It will have data which you put into the genesis block, and it knows that it should be sequential and it cannot be changed. So that is like the foundation. So this is about this. Let's keep going. We'll recap what all we have learned. So first, what did we learn? What is a transaction again? How is it linked to blockchain? And what else did we learn? We learned the structure of the blockchain, that is block. What is the structure? Header. I'll just go back so that you will have a clear picture as well. Header, transaction, and a hash. The header has this information like timestamp, the version, and the nouns. Nouns is nothing but the address of the other blockchain from which chain it has been coming. Merkle root is nothing but encrypted address of these, and the previous block hash is nothing but the address of the previous block which it is connected to. And it has transaction. Transaction is nothing but the actual data stored. It might have the information about data. It might if it's a transaction of money or something like that, the value of that, and also the value of the data shared. Let's say we share data of some MB or GB, so even that it will be having, but the timestamp will be only in the header. And in transaction it also has this who has sent and who has received and where the transaction took place. So the whole data which needs to be there, ascending to descending order. Yes, okay, I just saw it in the chat. The Genesis block will not have the information, but it goes on like this, A to B to C. Yeah, and the second part is the transaction, where the actual data is stored within the block representing exchange of values. So it has the name of the sender, receiver, the amount, and the relevant details. But this transaction will not be seen to the common person, or it's not transparent. Everybody will know this, the transaction took place, but nobody will know what is in the transaction. The next part is hash. So that is nothing but the unique ID each block hash has, and this hash is carry forwarded to the next one. So that is how the addresses are stored. And and the next one is transactions in a block. Transactions is nothing but, that's what the thing which we are repeating. Transactions are exchange of digital assets or data. So let's say a digital asset is nothing but some amount, the thing which holds some value, right? So all these together, let's say a bunch of transactions together are bundled in one single block. Then transaction represents actions with a blockchain network, such as sending cryptocurrency, recording ownership, or executing smart contracts. So we also learned how to include these transactions in blocks. Let's say a group of things, similar things, can be formed in a chronicle change, that is like is A, B, C, I mean like in a perfect series, and they all are kept in one single block. So we can include all these transactions in a block, but not each single data is one block, but it's a group of data kept in one block. So again, linking these transactions with block is nothing but having a bunch of blockchains together. Like let's say a one single block, we might have a chain inbuilt, and all these chains are connected. So, and then the next topic was blocks and chains. So how are these blocks connected? The answer always will be linear sequence. Please remember that. The linear sequence is very much important to understand blockchains, because there cannot be any other series. Like it cannot be connected to A to D or A to E, but then it should be A, B, C, D. So that's how the linear sequence matters. So it forms a chain as usual, and each let's say B will have the information, that is blocks hash, the ID of A. So that is how it goes on in a blockchain, and A might have different blocks, blockchains included in it, right? And when we were talking about the starting block, it's called as Genesis block, we didn't talk about something like what is the end block called, because a blockchain can never end. It keeps on increasing as more data is entered or more people are joining. The blockchain keeps continuing, so there's no end for a blockchain. And the starting will be Genesis block, because it is like a foundation for all of that. And the third part, why do we need to link the blocks? Because once it is added into a chain and other block has information about the first block, it's very easy to ensure the security, and it's very easy to ensure the immutability of the blockchain. So that is the main reason behind linking the blockchain. So when somebody might question you, why should we link these blocks? What is the reason behind it? Can't it just be a block by block, and can't we just have the information? So this is the reason, that is so that we can ensure immutability. So that was the concept which we learned yesterday. And let's go to the next topic, what we learned. we learnt about the genesis block and how these blocks are added together in a chain. So yeah, I'll just take one more session and we'll give for some time for the Q&A. Great. So I'll move forward. The next session will be, okay, if you have any questions, please let me know for this, about this session, about this topics which we have covered today, so that I can clear them out. I'll wait for 2 minutes. Please let me know if you have any questions in the above topic. I'll be waiting in the chat box. I hope you'll be putting your questions. Meanwhile, I will open the next activity so that we can understand. If you have any questions, please put it in the chat box. If no questions also, please put it in the chat box that you don't have any questions. I'll just take a minute. Please let me know. So I understand that there are no doubts at all. No questions. Great. So I will jump on to the next session, that is a group activity. So till now we have learned what is a blockchain. Till now we have learned certain things. So but how to make them understand, in a better way. So this is an activity. So we can, if there are many teachers watching here, so this is the perfect activity to get the students involved, get the students understand the concept, and to make the blockchain concepts in a clear way. When they see the board and the definitions, it's not going to really, maybe it's not that effective, but these activities will help them a lot in getting involved. So let's divide. It would be great if you could divide yourselves. Let's divide them into 3. The one will be block builders. So these let's say a set of 5 people will be there. Each person will write certain set of information related to other. Let's say you all come up with one topic. I will talk about school admission. So let's say first you need to find the best school in your area. Second thing, you need to go to the administrative block to ask about the admissions. Third thing, you need to take a form, fill it up. And fourth thing, so it goes on, like it goes on a series. So these block builders will be coming up with a topic and they will be doing a thing on that. And chain connectors. These chain connectors are nothing but as I told, you have to have the next block related to the previous block, because that is what refers to the hash value which we had before. And the validators. Validators are one more set of people who would be checking if these blocks are connected, if these blocks are interrelated, and all of them agreed in one. So just take a paper, write down whatever is there, and make that's how this should be going on. And so how to make the blocks? Like let's say each block has some set of information. So they contain certain set of information. So each person is like a block and they'll write some information related to it. Let's say a person is a genesis block and he or she will start it. And while it goes on to the next one, it should be related. As I told, just let them take a topic, let it be related, and let them write. So these should be fun. It should be like a fun topic so that they will also enjoy in the student point of view. So this linking blocks. So as I told, how to connect them? They should be connected in such a way that each topic, like let's say block A is related, block B is related to block A, something related to block A for sure. So it should go on sequentially, A, B, C, D, and once the information is passed, let's say person A is passing the information to person B, it should be noted down. coming to this consensus mechanism is nothing but it's like when you live in a society, you have certain set of rules to live by, you have certain set of things to follow, and everybody should agree on it, because if one person has a problem, that means there is some disagreement happening. So you should let the group come with one topic where everybody agrees it. And we also have a topic consensus mechanism where we are going to discuss deeply about it in our further sessions as well. But this is the basic thing. This will be like the introductory slide for them, so that what do we say, like it's an introductory slide to them to understand what is consensus mechanism, where everybody comes to an agreement. So this thing should be done while you are building the blocks, where everybody will come to one single topic and they will start writing facts about it. And the third part is validators. Validators should check what is happening, and if everyone agreed and it's valid or not. It's not just everybody agrees, but it should be valid. But then there is one more point, and one person should act as the transaction recorder. So as we told, we in blockchain we have a ledger as well. That is, in the first session we were learning about it, where we have the transaction details, everything written in one single place. Like every block, when let's say one transaction happened from block A to block B, so all this should be validated and written, like this transaction has happened. So when students, a group of 5 people are sitting together, if person A is giving the information or passing on it to the person B, our ledger or whoever is recording the transactions will stand and record that transaction from A to B has been done. And when it goes on B to C, he'll write down a transaction with a timestamp or so, like at 12:55 this person has sent some set of information to B. So after all this is done, we can make the students stand up and just read their points, and if everybody has agreed on it or not before in the discussion. So this ensures that they have they'll understand Genesis block, that is the leader or whoever is the starting with the topic, or whoever is writing the first point. And then block B, when it comes to passing on the information, as block A had something related to that, it's like the hash value sent to block B. So some certain set of value has been sent to block B, and so on, it goes on. So that, and it should be linear format. So let's say we tell them to write a process like school admission or bank account opening or so. So when we give them this, what happens is they have to know that it goes linearly, like it goes series by series, if step by step process. That is the best way to explain it, right? So in this step by step process, if A is doing something to B and B is sending something to C, so each value, like when C is trying to write a point, it should be related to B. So that means it is holding a hash value in C. So once that means your information is related to this. If one person will try to change the thing with B, everybody else will, let's say we start a blockchain, we are writing about the process of admission, and suddenly some person comes and changes the B to process of restaurant, putting up a restaurant. So whatever the next points you have written are completely like not even related to it, and everything is going to get disturbed. So there we can teach them about how, if one block is changed, how the whole group or how the whole blockchain is going to get disturbed, right? So we can use this concept there in order to get it done. Next, validation process. These while validation process is been take place, we ask every student to read them one by one, and this validator needs to ask all the other group of in that blockchain to, if they all agreed with the consensus mechanism, and did they all come to a point, and is it valid. If let's say one person is saying this is not related to us, that means they disrupted the blockchain, right? So the validators should be able to validate, if it's correct and if everybody agreed on it and if it's valid or not. So this is how you can bring up the blockchain into them. You can involve them in a better way to make them understand the blockchain technology. And the next part is ledger. So whenever a transaction is taking place, we should make sure it is done with the timestamp. And the timestamp should be written with a column called header. In the header only we note down the timestamp. We note down some set of like previous one, let's say A and B. So we write down A to B and then we write down B to C. So that will just make a column header, and here are the transactions. So that will ensure them to understand how header works, what is stored in the transaction. The transaction is nothing but the block which they have and who's sending to A. Like let's say we'll give them papers and let's say person 1 is A, we write down A. So we know that A is sending to B and they're interconnected. And we, in the transactions part, we make sure that A and B is sent. The transaction is nothing but their information which is there in the block. So here it is header, transaction and hash. Hash is nothing but again the unique ID which the data has been transferred. So we can just make them use these columns and we can divide them among them into the groups, and yeah, that's how we can do it. And the last part of this is challenges and discussions. So while they discuss about these things, we can ask them what are the challenges they faced, what are the problems they had, like while let's say like while coming to a single topic and writing something's related to it to come up with the process and so on. When I was taking the offline session, a few people were telling what were the challenges and what they learned as well. So the challenges was coming up with one single topic, coming up on agreement. Everybody had different point of views. So in a blockchain, to ensure this credibility, to ensure to have a group thing, we need to make sure they all come under one single agreement and it goes on. So that was the challenge one of our students, as one of our teachers have shared with us. So you can also put it in the chat box if you think there are many more challenges that will be faced during that, so that we can make the concepts even more better for them. So they can also share how we can make this blockchain better, what all we can add into it. So this will get their mind to get into points and to think about real world examples to involve them as well. So this will be the session for today. If you have any questions, please feel free to put it in the chat box. I will be checking the chat box frequently, so please put up all the things if you have anything. Yeah. I will wait for 5 minutes and so that you can let me know if you have any questions regarding this activity or even in the previous session, so that I can be clearing them out. We have half an hour for the Q&A session, so please let me know. And I've heard that you'll be having assignments further, so please make sure you have a note about everything we have done in the sessions, and also please let me please come up with new ideas how to come up with good activities for blockchain if you have any, so that it will be more interactive and involved. If you have any questions, please let me know. Please put it in the chat box. If yes, yes. If no, and please put that no questions also. So I assume there are no questions. I have been seeing the chat box, so please let me know. If there are no questions also, please put up in the chat box so that I can understand if it's clear or not, so that I can get a feedback. And please come up with even more better ideas where how we can include the blockchain, how we can include the topics to understand it better. And if you understood this blockchain, please let me know as well. No questions, great. If anybody else, if you have any questions or queries or any suggestions, or how we can include new activities into blockchain to make them understand or to make it clear, please let me know. I hope you all made a note of the previous sessions as well. Let's try to make it more interactive so that it will be clear for you as well as us. So I assume no questions so far. I will just put up this other session, just have a look, and we can end the session. And we'll be meeting tomorrow. I hope you're recording, or you have all the slides, or you're noting down whatever is given here, because I've got to know that you'll be having assignments or so. So please make sure you have a note about whatever we have here. So I assume no questions, and I think we'll be ending it here. Please let me know if you have anything, put it in the chat box. I will at least answer them tomorrow also.